Welcome back to Forging a Minecraft Mod, lecture number 3, Basic Block. So before the break, we created a basic block, obviously. We had different textures on different sides, and when we stepped on it or activated by redstone, different things happened. We also made sure that the player could activate and disable and enable this feature, and we did so by using onBlock activated here. So we got the metadata and swapped that. So we had 0 before, we used 1 as the new one. If we didn't have 0 before, we used 0 as the new one, and then we set that like so. We used 3 as the flags here to sort of define how it would update it. And here's what we did. We had, where is it? We had is disabled here to tell it if it's disabled or not, depending on the metadata, and we used that to define which texture to use. Okay, so what's the next thing to do? Well, I'm going to actually go back to what we did last lecture, the item card here. And if you didn't remember it, what we had was just 3 different cards, 3 different names with 3 different icons. We had the arrow card, the border card, and finally the cross card. Now what I'm going to allow that to do is to do different things when we click with it. So what does this have to do with the the blocks? We'll see in a bit. So the method I'm going to use is public boolean on item use first. So that's going to be triggered first when we right click the item on a block. And the stack we use will get us the first parameter. The second one will be the player that used it. I'm not going to use that one. And then we get world. I'm definitely going to use that one. So then we get the coordinates like so, but we also get the 4 ones we actually got in the block as well. So we get the side, we get the hit X here, we get the hit Y, and these are the exact same thing as the ones we had in that method we used in the block, the activation code there. And there we go. Right, and I need to, of course, import these 2 things. Control-Shift-O, and the trick is done. Now we'll obviously get an error because we're not returning anything at all. And what I want to do here is, allow you to right-click with a card, any of these 3 cards, and that sort of card type is going to store it in the block. If you've taken a look on the textures that I have in the texture folder, you'll see that we have 3 different side icons depending on the different cards. So we have 1 arrow side, we have 1 border side, and we have 1 cross side. So what do we want to do? Well, first of all, what I want to do is make sure that we're not on the client side. We've done that multiple times before, but the next thing to do is just to get the block ID at the block we're clicking, so we can get information about it. No, that's the metadata. There you go. Block ID X, Y, C, like so. And then we can just compare that to the the blocks.machine.block ID, because that's the block ID of the machine. And since each and every blocks have unique IDs, that's the point. We know that if the ID of the block at that specific coordinate is the same as the ID of our base block here, that means that we just clicked a machine block from our mod. However, since we have block info.machine ID, we can use that as well. It doesn't really matter. There we go. So what do we want to do here? Well, if we clicked on that block on the server side, we want to return true. What does this mean? Well, it means that we've done everything we want to do, and all the normal stuff, you should just ignore them. So if we used the card and clicked on, for instance, a chest would obviously open and we can take a look inside it. But if we click on something else, like the machine block, we don't want it to change its disabled state. So if it was disabled, we don't want it to be enabled just because we clicked it with a card. So by returning true, we prevent all the other things from happening. during this right click. But if we return false, the normal stuff will happen. So basically what this means is if we click something else, like a chest, we're still going to be able to open it, but if we right click on a machine, we're not going to do anything with it. Well, we're not going to allow the block itself to swap states, basically. Okay, so this is obviously not the only thing we want to do. We want to change the metadata. That's right. So the metadata I used before was, well, I just had 0 or 1. 1 meant it was disabled, 0 meant it wasn't, it was active. And I want to introduce something else as well. I want to introduce a way of setting in different types. So I have one type where I haven't set any of these cards to it. I have one where I set it to be an arrow, one where it is a border, and one where it is a cross. I think that makes sense. So what I want to do first is get the old metadata by using world.get block metadata like we've done before, X, Y, Z. Nothing special like here. And then I can just get disabled. How do I get if it's disabled? Well, I can check if it's like meta is not equals to 0, for instance. But, well, if I want different types, the way I'm going to set this up now is, well, we will have, if it's an odd number, it is disabled. So every second number is going to represent this block is disabled. Why do I do this? Well, that means that every second metadata value is a valid one to tell that it's disabled, and that means that we sort of have grouped each of the values in pairs. We have one enabled and one disabled, one enabled and one disabled, one enabled and one disabled. So why would I have something like this? Well, then we can tell each pair to represent different types. So we have the two first values would be the first type, the two second values would be the second type, the three, yeah, and so on. So that means that we have, for each type, we have one disabled and one enabled version. So to see if it's disabled, we will just do meta mod 2, and that's going to give us a 1 here if it's disabled. How do we get the type that we want? Well, remember that we store in the item stack, we store the item damage, where we have 0 for the arrow, 1 for the box, and 2 for the cross. I want to have 4 different types. I want to have blank and these different 3. So what I want to do is just add 1. So I have the type 0 means that it's a blank one, and then we have 1, 2, and 3. Right. How do we calculate the new metadata we want? Now, well, we take the type, multiply it with 2. That means we're going to get us into the correct pair of these different values. Remember, we have enabled, disabled, enabled, disabled, enabled, disabled, and so on. And then if we just add disabled here, we're going to add 1 if it's disabled, which is going to take us to the value which represent the correct type, and if it's disabled or not. So all of a sudden we're using the metadata. Remember, we have 16 different values to use. We're going to use that to store 2 different types of values. We're going to store which type it is and if it's disabled or not. So we will have 4 times 2. We have 4 times, and both can be disabled or enabled. So we'll use 8 different values, which is totally fine because we have 16 that we can use. And the thing we can do then is just set block metadata with notify X, Y, Z, new meta, and the final thing is 3. So remember, this 3 is just here to tell it how to notify the block update. And usually you want to go with 3, but you can go with other numbers. So if you don't know what's going on there, just add 3 as the flag there. Is this it? Well, I want to do one last thing. If you right-click the block with your cards, then I want the card to be removed. Or, well, if you have 2 cards, I want you to just get 1 card. If you have 1 card, I want you to get 0 cards, and so on. It's very easy to do. Just decrease the stack size with 1. We will have to note one thing, though. If we have 1 item and we decrease it, we will get a stack of 0. We don't want stacks of zeros, so we'll have to remove that stack. So if we have a stack with no items, remove the stack completely. But lucky for us, on item use first is actually taking care of that. So if when that has happened, if the stack size is 0, then it's going to be removed, so we don't have to think about that. But one thing to remember, a stack size of 0, so we have a stack with no items in it, is not the same thing as no stack at all. So usually we'll have to make sure that if the stack size is 0, remove the stack completely. Here it's taken care of for us. So there you go, this is everything in the card item card class, and what I want here is basically if I right click the block, the machine block with the card, we're going to change the type but preserve the disabled state. Right, what we want to do now is go back to the machine. So we've changed a lot of things, not in the code, but how we think about it. Now is disabled is not if the metadata equals to 1. Now it is if the metadata mod 2 equals to 1. So each and every, well, each second metadata is that it is disabled. So that's one thing that we need to do. Another thing that we want to do is have different textures for different types. And, well, how do we do this? Well, the basic way would be to just change machine side to machine sides, and then just give us an array of icons. We've seen how we have this before with the cards. Of course, that will work for the items, but it's the same idea. So I will have machine side arrow, and of course we need these textures to exist, but if you've taken a look in the folder, you'll see that they are there. I've already prepared them. Machine side box, and finally machine side cross, like that. There you go. And now I can use that. Of course I will get errors like, oh right, I don't know what machine side is. So what I'm going to do is rename side icon to side icons and create an array like so. And like I said, we've seen this before, so I'm not going to cover it very much. I'm just going to take you through this. So we have side icons here, and we want to create a new array of the same size as block info.machine sides length, like so. And then when we've done that, we just loop through the different elements to register these different icons. So for I equals 0, I is less than side icons dot length, increase it by, like that. And instead of just register one icon like so, we register the icon at a specific index with the texture location at a specific index. Like I said, we saw this last lecture when I did it for the cards, so I'm not going to go through this more than I've done now. So just loop through them and add them to the array. Okay, now we can do the same thing here to return the correct type. How do we calculate which type we currently have? It's quite easy actually. We just take the metadata and divide it by 2. Since this is going to be integer division, if we have number 0 or 1 as the metadata, we're going to get type 0. If we have metadata 2 or 3, we're going to divide that by 2 and get type 1. If we have 4 or 5, we're going to get type 2, and so on. So we can just do it like this. There we go, we divided by 2 and then use that type there. Of course we could just do meta divide by 2 right away, but well, this sort of, yeah, shows a bit what's going on. We just calculate the type and then we use it like so. Right, so now we have, so it shows different textures depending on the type, and we've defined, so it's calculating if it's disabled or not by using the metadata itself, using mod 2 rather than just checking if it's 1 right away. But one more thing we'll have to do actually, and this is the part here on block activated. World.isRemote, that's the obvious one, and then we just say that, well, if you were ID 0, then you should have, well, not ID, metadata 0, you should have metadata 1, otherwise we should go to 0. This is obviously not the case anymore. If we just go like this, as soon as we try to disable it or enable the block, it will lose its type, and that's not what we want, so we'll have to write a bit of a more advanced code to handle this. So what I'm going to do is define a variable called meta, like that, for metadata, so we just get that one. And then we can calculate the current type. The current type is of course meta divided by 2. We did so up here as well. So that will give us a type. Then we want to calculate if it's disabled or not. So what we do is, well, I can do it like this: meta mod 2 equals 0. If that's the case, then what I want to do is give it 1, otherwise 0. So here's the same thing, the same code that I did before, where I got the metadata and said if it's 0, then use 1, otherwise use 0. Right. So it's the same thing, but instead of doing just meta equals 0, I use meta mod 2 equals 0, because that's how we check if it is disabled nowadays. And finally, we want to calculate the new metadata, and it's fairly simple. We've done it before. Type times 2 plus disabled. So we use the old type, the one we got from the metadata itself, but we have reversed the disabled value, and then we just put them back together into the metadata like so. So let's see how this works. Here we go. Lecture number 3, or well there, called lecture 3. And let's see now. So let's grab the cards from last time. They are in miscellaneous, if I don't remember wrong. There we go. And what I want now is right click and boom, look at that. So it's going to store that. Boom, boom, works perfectly. And as you can see, I'm losing one item at a time here. If I have multiple ones here, there we go. Nice. So we have it like this here. So we store both. Remember, we store both the type and the disabled value in the metadata. So we can't just say, well, the type equals the metadata, because then we can't store if it's disabled or not. So we can have different types, and we can also have if they are disabled. If I run here, it's not going to cause a problem. If I run over here, it's going to drop an anvil like that. So we have a metadata, we store multiple values in it by, well, grouping them up like 2 and 2. We can take a closer look on that. I'm going to represent that with blocks so you can understand further what's going on. And I'm actually going to need to scrap that. Okay, so what I have at the moment is the following. I have it set up like this. Oops. Here we go. So they are grouped 2 and 2, and here we have enabled, disabled, enabled, disabled, enabled, disabled, yeah, you know. And then each of these types are grouped 2 and 2. So we have the first type, which is the blue one. We have the second type, which is, well, this purple one. We have the third one, which is the yellow one, and then we have the green one. So we have 8 different values, but we'll set it up when we read the values that every single, well, not every single one, every second one is the disabled one, and then we can group them 2 by 2 to get the types. Obviously, this is not something that is built in or anything. That's just how we want to represent the metadata. We get from 0 to 15, and we can do anything at all with those numbers. Of course, we are restricted to just be between 0 and 15, but if we are there with the numbers, we can do whatever we want. The next thing I want to do is actually do different things depending on well, the type. And what would that be? Well, I wanted to spawn the anvils differently depending, well, when we get a redstone signal, depending on which type we do have. So how would I do this? Well, first of all, what I want to do is take that code. So this is just the code calculating metadata, and put it here instead. Here. So I can use it multiple times without having to ask for the metadata multiple times. So otherwise it would have to be calculated multiple times. And then I just want to do switch meta divided by 2, like that. And that's going to give us the type. Remember, the types are grouped 2 and 2, so we have one enabled and one disabled version. So therefore divided by 2. And what I want to do is have 3 different things here. three different cases, and of course I need a break in each of them. As you can see, I'm not using, or well, doing anything for case 0. So if you haven't added the card here, it's not going to do anything when it receives a redstone signal. That's just how I decided to design this. So what do I need to do? Well, I'm going to do quite a lot of things, and to save time I'm going to copy them in one by one and describe them rather than code them. So here's the first one. This is if we have the arrow. It's type 1. We loop through 5 times, and then we spawn a anvil at that specific location 20 meters up plus that one, the value of the loop. So we're basically going to spawn 5 anvils on top of each other. The second one I'm going to use, that's the border one, the box one. That is going to do the following. So I'm going to loop from I equals -1 to I equals 1 like that, and it's going to spawn an anvil like this. So it's using the I as positive, as X here, with C being negative and C being positive, and then reversed for X and C, so they reverse place there. And what this is going to do is create a border around the block that spawns them. And the third one is the cross. And what I'm going to do is loop for I equals 1, 2, 3 basically, and in all 4 directions I'm going to spawn anvils. So yeah, no, I went through this quite quickly, and the reason why I did so is because it doesn't really have anything, well, not much at least, to do with what we're currently going through. I just want the type to actually do something, and what it's going to do is just spawn anvils in different shapes. We'll take a look on that. But of course, like any other lecture, this source will be uploaded afterwards, so you can just get it and poke around with it to see exactly how the shapes are defined. So let's get rid of these different things here, and I need to get that last card again. There you go. And alright, a button as well. So if I put this down here and give it a button, remember I have to shift click to place the button, otherwise I will just change the state if it's enabled or not. If I do that, nothing will happen. If I give it an arrow, it will spawn 5 anvils on top of each other. If I use the border and click it, it's going to spawn a border for me, like so. If I give it the cross card and click it, it's going to spawn a cross like that. So like I said, I didn't go through exactly what the code did, but as I gave you a brief description. But like I also said, it doesn't really have too much to do with what we're currently using. You just got a few different behaviors there depending on the type. Well, what's the next thing to do here? We'll take a look. I want more of those. So we have different things here. I've set it up differently. Let's add a cross there, like so, and it looks all fine. They do different things, right? So what if, hang on a second, I need a pickaxe. So what if I break all of these? That would make sense, right? You want to pick it up. Game mode 0. Okay, so break this. Boom. We're having problems here, as you can see. It's not remembering what it was. As you can see, look at that. It's just the default one. Nothing is sort of happening. And if I place them, they are just back as they were. And I don't want that. I placed a card on them. I wanted to keep that state. So how do we do that? Well, we have 2 different steps that we want to go through to make sure that that works. So the first thing we want to do is go into the block here. I'm currently in block machine, like I were just a second ago. I want to override a method here, and that method is called damage dropped. So in the beginning of the lecture, I spoke about when we create a block, we need to give it a item to be associated with it. Or if we don't, we're going to get an item anyways. So each and every block has an associated item. So if you break a block of dirt, what's dropped on the ground is not not something containing the block, it's something containing the item itself. And a dirt item, that's something else. When you pick it up in your inventory, you will have something referring to, well, a dirt item, not a dirt block, a dirt item. And when you right click in the world, this dirt item knows that when you right click on the world, well, on a block in the world, we want to place a dirt block and remove the dirt item, well, one of them. And that's sort of the same thing that we do in here, really. When we right click on a specific block, we want to remove this item and do something. That's the same thing for all the different blocks. When we have the machine in our hand, we have something called a machine item. Basically, we don't have the block, we have the item. And when we right click in the world, it knows that, well, I should place a block here and remove myself. So that's handled without us knowing, or well, we don't have to care about that. But obviously this item that is being dropped can have a damage value, because, well, an item stack can have a damage value, like we saw with the cards. So here I can override damage dropped and tell it, well, depending on the metadata of this block, when it's being destroyed, I want to return different values that is going to use as the damage value of the item that we can pick up. So now when we break a block, it should, well, the item that we have should get the correct damage value and therefore remember what state it was in. There we go. So let's see what's happening now. I'm going to give these a few different states here, and I can like disable those two, and boom, look at that. If we take a close look, you can see that one is disabled still. Come on, slime, simply don't. Like that. And if we escape the slime and pick these up, we'll see a problem. They do still stack. And when we place them down again, even though they look different when I have it in my hand, they will still spawn the default ones like that. So we do have a problem. It's going to save when we break it. It's going to, well, anvils. It's going to store that damage value inside the item, but there's nothing telling the item that when it's being placed, it should use the damage value as the metadata. And, well, we can't really change that in the block. So what do we have to do so, to make sure that this works? Well, the only thing we'll have to do is tell the item itself how it should be placed. That seems fairly easy, right? Well, apart from that, we don't have an item of the block. Well, like I said, we always do have an item, and if we want to, we can specify exactly what item we should have. So what I'm going to do is create my own item that we will associate with the block. So like I said, when we create a block, we'll get an item that is associated with it, unless we create our own item that we define so that it is associated with it. So how do we do this? Well, we're going to create a normal item with a few differences. So there we go. I'm going to zoom in there, and instead of just extending item, I'm going to extend item block. It's still an item though. There you go, because item block extends item. So if we take a look here, we open declaration, we can see, well, this item block extends item. So our item machine is still an item, but it contains information from item block. What is this item block? Come on, what is it? Well, this item block is, well, the item you hold in your hand when you want to place a block on the ground. For instance, for a dirt block, you have a dirt item. This dirt item is of the type item block. When we created our block machine and wanted to hold it in our hand, we hold a item block that was specifically created for our machine. So what we're actually doing here is we're not actually doing that big of a difference. We're still going to use, well, we're going to use our own item, but that item is still an item block like that we had before, and therefore we don't have to do so much code here. We don't have to write that many lines of code, because we're extending what we used before. So the only thing we have to do is override the method and give it a difference. Of course, we need a constructor here with the ID, and it's just a matter of sending that along like that. And the second thing I want to do, so I only need to do one more thing, and that's the following: set has subtypes, I think it's called. Yeah, there you go. Set has subtypes to true. So I want to set it that we have subtypes for this, and when that's done, the constructor is all sorted. Everything else is taken care of, so we just give the ID along and set the subtypes like so. And like I said, I wanted to override one single method. It's quite easy what it's called. It's called public int get metadata, and we get the damage. So what we're doing now is that we have, where is it? Here, block machine. In the block we define, when we break this block, we want to return which damage value the item should have depending on the metadata. Inside the item here that we're going to associate with the block, we want to get the metadata of the block from the damage value of the item. So we're basically doing the reverse thing here. In the block, we go from metadata to damage value. In the item, we go from damage value back to metadata. So now we would be able to pick it up and then place it down again. I'm just going to return the same here. So when we convert it, of course you can return other things here, but what we're going to do is we're just going to return the metadata that we want. So it just converts very easily. The damage value is equal to the metadata, and when we convert it back again, we obviously do the same. It's totally fine to do it like this, but we could return other values as well. And the default thing in item block is that the metadata is always 0. So when we place an item, we want to give it the metadata of 0. And that's why it didn't work unless we extended this with our own class, our own item. But apart from returning the metadata as being the same as the damage value, we're not doing anything at all. But, well, we have a problem. How is it supposed to know that this item machine is the item we want to associate with the block? How do we create this item? Well, shouldn't we do it like the other items? Like this? That seems to make sense. But we don't want that. Here we just create a new item to be used as a normal item. If we want to create an item associated with a block, what Minecraft is going to do for us is, well, FML or Forge or whatnot, is it's going to create a new instance of this item that we can use for the block itself. But that means we're going to create a new instance of the item when we actually associate with it with a block. And remember, we should just have one single instance of an item. So I want to stress that do not create a new instance here of that item. If you make an item that is just supposed to be an item, then do it like this. Do like card equals new item card blah blah blah. But if you create an item that is supposed to be associated with a block, like being the item representing that block, you shouldn't do this. What we should do instead is register that this item is, well, the item representing the block itself. So what we want to do is, during this registration, when we register the block itself, we can just give it the block and the key that we want to use, like we do here. But what we want to do now is give it the block, the item class, and the key. So if we add here item machine dot class, so we can actually do that to refer to the class itself and import it, of course. So what we have now is the block, we have the class of the item, and the key. So what it's going to do is, well, it's going to create a new instance of this and just use that as the associate item. What did we do before? Well, by not specifying anything there, it just ended along item block dot class. So if I do it like this and of course import it, it's going to be exactly the same as what I did before. It's just that if I don't specify the class at all, it's going to use item block dot class. But what we're going to do, of course, is item machine dot class, which means that we're going to use our special item, which doesn't contain too much code. The only thing we have, which is not a part of item block already, is that we have multiple types and we return the metadata depending on the item damage. So let's run the code here. Right, so let's open the world here. Oh, bloody slime. There you go. So let's see now, if I break this block here, it's going to drop it like an arrow there. If I pick it up, as you can see, it still has that arrow, and if I place it, boom, it's working. So you can't really see too much of a difference because it looks the same, but actually when I hold it in my hand now, we actually have the own item. We don't have the come on, slimes. We don't have the item block item, we have the item machine item, which is, like I've said multiple times, is mostly the same, but now if we break it, we'll get it like we had it before, so we won't waste the cards. And it's getting dark, let's fix that. There we go. Before I am going to end this lecture, I want to show you one last thing. It's nothing new, it's just a handy thing we can do. Obviously now we have multiple types, and therefore it might be nice to show them all in the creative menu, the creative inventory. So what we can do is exactly the same thing that we did for the cards. Side only, side.client, not that, and we use public void get sub blocks. Of course, this is not what we used before. We used subtypes or sub items or whatever it was called for the items, but it works exactly the same. We get the exact same things, and we do it in the exact same way. So what I'm doing now is just looping through the different sites we have, because that's obviously the different types we have. And of course we could loop through the different if it's disabled or not, but I don't see a reason to add 8 different items in the creative window when we could add just 4, and the only difference would be that when you place it you can right click it to enable or disabled. So of course we don't have to add all the items that we do have as sub blocks here. So this get sub blocks are only the blocks we want to show in the creative windows. They are not all the blocks that we do have. So list.add new item stack. I just give it the ID like before, 1, because, well, it doesn't matter the amount, and then I times 2. So I represents in this case the type, obviously, because I'm looping through the different types here, there. And since the type, or the new metadata, is defined as, well, type times 2 plus disabled, I would have to do type times 2 plus disabled. But since we never want these items in the creative window to be disabled by default, I'm not going to add anything there. Or if we want them all to be disabled by default, we can just do +1 there. Nice. Import this all and pick the correct list, the java.util list, like we've done before. Like that. And now it's complaining, I don't know why. Okay, so misspelled that. It should be get sub blocks, not get sub block, and it shouldn't be side underscore only. Sorry about that. There we go, much better. So like I said before, we're doing it in the same way as we did with the cards, but the only the two different things are, first of all, we're using blocks instead of items, so the method is called something else, and second of all, we're not showing all the different types that we have. We have 8 different types of blocks, but we're only showing 4. Why do we only show 4? Well, the other 4, that's not the one I want. The other 4 versions aren't really that interesting. It's just the same, but they are being disabled instead. So as we can see, we have these these 4 different Scylla machines, and of course they are all called the same because we haven't set it up in any other way. As you can see, I got the Scylla machine with the border here, and I'm just placing it like this. I can spawn a border of anvils, like so. If we wanted them to have different names, we would only give them different unlocalized name and then just register different names for them, like we did for the different cards. We have arrow card, border card, and cross card. It works the exact same. If we want to add recipes for blocks, we also do it the exact same way. So a lot of things works exactly the same as with items, but of course items and blocks are not the same thing and therefore works differently as well. Right, so that's about it for this first lecture about blocks. We'll talk a bit more about blocks in the next lecture, but what have we actually been talking about today? Let's take a look. Right, so we started with the basic block class. We have public class block machine extends block. Fair enough. We need an ID that we, well, get from our config, but we also need to send along a material. Here I'm using material.iron. If we wanted to, we could create our own material as well. And we could also have that material as a parameter, of course, in the block machine, so we send that along. Here I'm just getting the ID and always defaulting to iron there. We set the creator tabs, and we also set the hardness, how tricky it is to break, and the step sounds, what sound it should give when we're moving on top of it. And then we can extend multiple methods there, but they are of course multiple, so you override the ones you want to change, the ones we want to change the functionality for. And here we have the icon, so we can have a method called public icon get icon, and we get the side and the metadata. Here we only use the side, so if the side is 0, we return the bot icon. If the side is 1, which is the top, we return the top icon. Otherwise, we return the side icon. We saw when we use the metadata that we return the top icon differently depending on if it was disabled or not, and then also later on we return the side icon depending on which type the block had at the very moment. Here we go with some redstone. We have, well, on neighbor block change, so we'll get when a block nearby has been changed, and then we can check if the block is indirectly getting powered. Of course, we can also make sure that a block sends power, but we haven't gone through that. And like I said as well, this is not a very good way of detecting if a block just received a redstone pulse, because if this block is updated anywhere else, it's still going to trigger this code here. So what we will have to do is store the last value of the redstone state, which we can use the metadata for. And one of the exercises is to add that to the existing block already, so it works properly. Here's the metadata here, so we can check the metadata by just doing world.getBlock metadata and give it the coordinates in the world. Or we can set the block metadata with well, the given coordinates, and I see that that comment there is not the correct one. It's from the last one. It stayed there. I'm going to fix that. And when we do set block metadata with notify, we give it the coordinates, the new metadata we want set to it, and finally a 3 to tell how it's going to update this. This 3 can be replaced by other numbers, but this 3 is probably the one you want to go with most of the time. Then we can register the blocks. We will have to do that, and if we just want to do it normally, we just do game registry.register block and then the block and a key name. While if we want to give it a specific item, we do the block, the class of the item, and then the key name. And observe that we shouldn't create a new instance of the item machine. That's going to be handled when we register it. So do not create your own instance of the item itself. We create a new instance of the block and then we give it the class like so. And that's about it. We have the questions and exercises as well, so take a look on them afterwards. Questions to see if you've learned everything, exercises to practice these things, and further explorations if you want to take a step further on. We have answers to the questions and possible solutions to the exercises. However, today this document is a bit delayed. It will be uploaded eventually. I'm sorry about the inconvenience there. But that's about it. This has been Forging in Minecraft Mod, lecture number 3, Basic Blocks. I've been VSWE and I hope you enjoyed it. I hope to see you next time when we talk more about blocks and also about tile entities. Goodbye.